So in this video, we will see divergence. Okay, so divergence, we will get into Maxwell two equation. We will understand those two. Maxwell has given his famous four equation, as you know. We will discuss that for two equation whether divergence is involved. Okay, and after knowing divergence, you will able to understand lots of things. Okay, you will able to understand why the magnetic pole doesn't exist alone, means north and south pole alone. You have never heard of north and south existing alone. So why is like that? So let's dive into divergence. So let me give you a little intro about divergence. So what does divergence tell? It's actually a measured quantity. Even in physics, there's lots of measuring quantity. Source we measured in Newton, charges, Coulomb. So distance in meter, centimeter, something like that. So as divergence is measure the sinking in, whether the field is spreading out at a point or squeezing in or sinking in at a point. If the field is spreading out at a point, then we will call the divergence of that field at that point is positive, and if the field is sinking in, net flux of the field is sinking in, or net flux of the field is sinking in, we call it, and divergence at that point is negative. So you will understand it better. So if proceeded with the example, proceeding with example, at that point we can't take a point, so we took circle. At that point the field is, assume this arrow as field action. Okay, field is going in, only going in at that point, not going out. So the divergence will be negative. This is the divergence mathematical measuring expression. We will come into that later in video. So this is divergence. You got divergence is negative. Why divergence is negative? Because net field direction, field line direction, and field flux is toward the point, means converging to point or squeezing in tight. Okay, and this is squeezing, is mean spreading out tight. Okay, so the divergence is positive. If the field line is spread out at that point, then the divergence is positive, and if the field line squeezes in at that point or diverge at that point, it will be negative, and if it is spreading out, it will be positive. Okay, you can take we can take another simple analogy to understand as well as this. This is water is net water direction is sinking in. Okay, net water direction is going inside around this circle, around that point, and if you consider this circle as a point, you will know like divergence at that point is less than 0, means negative. Okay, so if it is spreading out, it is simple, it will be negative. If it is squeezing out, spreading out, it is positive, and if it is squeezing in, it will be negative. Okay, and we can take this example of as well. Here, see, here the divergence in this condition, we will understand it now. So see. Okay, so here the field, it is representing the field line, and if you say at point, okay, let's say we draw a field at this point. Okay, so what's happening at this point? The number of field line which is coming in, okay, is same as the number of field is going out. Okay, we are assuming there is no field generation at around this point. Okay, so if this happen, that if the number of field going in is equal to number of field line passing out, or number of flux of entering and exiting are same, we will call it zero divergence. So divergence 0 also exists. One is positive, negative, and 0. Here you can also say it's zero divergence. Okay, number of field line passing in is equal to number of field passing out. But if we come into if you see here, here field generation is taking place. So if you see here, the field is passing, exiting out more, means spreading out more than squeezing in. Less field is coming in and more field is spreading out. So it will have positive divergence. Okay, because net flux is spreading out, so it will have positive divergence. So we get to know three kind of divergence here: positive, negative, and zero divergence. Okay, this is the simple, like I told you what divergence measures. Okay, it can be any field. Okay, magnetic field, electric field, and any field. Okay, I hope you understood as far I have discussed. Okay. So that's what for that, and we will now going to dive into its mathematics part. Okay, why divergence is has written like that. Okay, we, as you saw previously, it is like dot with nabla operator. That opposite triangle is nabla operator, generally called, people call it gradient operator as well. Okay, so why now we will see like why it is only like that. Okay, what's the mathematics behind it, and how will we measure that field? Okay, how will we measure that divergence of any field at a point? Okay, so let's dive into mathematics. If you want to skip mathematics, then skip it. I will put that in comment. Okay, timeline. So this is the Maxwell two equation we're gonna discuss. Okay, both are on divergence. As you know, this is divergence of electric field, this is divergence of electric field. Okay, so before getting into that, you must know what is this epsilon. Okay, so this is the permittivity. It's called, okay, this, if epsilon is there, it's permittivity of vacuum. What that permittivity? Okay, so this is the value of permittivity constant, 8.854 into 10 to, that's E naught. That's what epsilon naught you have seen in that Maxwell first equation I was discussing. Okay, so if you see, if you have seen, this is what is still like divergence of electric field at any point is nothing but the charge density at a point divided by permittivity of that space. Okay, E naught is a permittivity of a space for, it is vacuum. Okay, this is vacuum permittivity, which is given as epsilon. If it's another permittivity, you will Google it. Different material has different permittivity. Okay, what permittivity physical thing, physical significance is still that how much that material uh, permits the electric field line. Okay, so that's why, and now we will discuss like why this is revolutionary. It is revolutionary because to find the divergence at any point, to find, we have to do nothing. If you see here, do know, if I want to find divergence. Okay, if I want to find divergence at a point, if I want to find divergence at a point, I will do what? I will find the density at that point. Okay, what I will do, I will find the density at the point. So if we want to find the divergence at this point, I will find the charge density at point. Means how much charge density is at point. Means more the charge density, more the divergence at a point. If the charge density is 0, then there will be no divergence. Okay, there will be 0 divergence. So if there is no charge, then there will be no divergence. So later this also like transform into Gauss law if we want so. But that's enough for our our objective to understand only Maxwell equation. So it's basic, like what does it tell? It tells how much divergence at any point of electric field is always be the charge density at a point, that point, divided by epsilon naught, which is permittivity, which is constant for different medium at that point. It will go down. And hey, now let's dive into second. Okay. If we come into second part, it what does it tell? It what does it tell? It tells us like magnetic field, divergence of magnetic field at any point will be 0. Okay, and this tells us like very good thing, like divergence of magnetic field at any point will be 0. What does it mean? If we see, what does it mean? Okay, it means that at any point, if you take any point, at that point, as much field is going in, as much field is point out. Maxwell tells that divergence of magnetic field at any point must be 0. So what does it mean? That, as I told, that means equal number of field, means flux passing in and passing out through around this surface or through that surface, closed surface, must be 0. So let's say, so what was our question? Our question is why magnetic pole can't exist alone. So if let's say magnetic pole north, we have somehow exist a north. Okay, so if north pole exists, as you can see from here, north pole magnetic, outside the magnet, north pole magnetic pole of north, like outwards, magnetic field point outwards or spreading out, okay, outside the north. Okay, so if that's the case, so let's say north pole is here, and we have somehow managed north pole existing alone. So if you assume it will point outward, okay, then you are wrong, because Maxwell tells it must be 0. So now if it's pointing outward, if you measure the divergence at that point, you will know, as we have discussed earlier, the divergence at that point will be 0, not 0, it will be positive, okay. But Maxwell tells the divergence of magnetic field must be always be 0, okay. So make it 0. What we have to do, we have to somehow close the loop. How close the loop? The loop will automatically be closed. So if it's north pole and it's only outside, it's getting speed up, but it is violating Maxwell divergence law of magnetic field. So what it will do, the field will come back in loop. So field will come back in loop, okay, and hence so that Maxwell's second law, which is magnetic field divergence is 0, doesn't violate. So it will make the divergence again 0. So if its field is passing out, it must come back. So that equal number of field pass and equal number of field pass in, that's why we will get divergence 0. So it must have 0 divergence. That's why magnetic field exists in loop. That's why it's an exists in loop. So if it's going in, it must come back at any point, because at any point the divergence must be 0. So at any point it must come back. You're getting the point? If any point, if the field is going outward, okay, it must come back in at that point, so that at any point the Maxwell tells the magnetic field is 0, okay. So if that's the thing, I hope you got it. The magnetic field, why magnetic field in loop, and why, if it's in loop, then it must be south pole there, because north pole nature is pointing out, magnetic field will point out, and the south pole nature is it will point inward outside the magnet, it will point inward. So if it's there, even their magnet pole, even if we divide it in half and we get a magnet, it will have north pole, it will point outward and it will point inside, then will obviously create a south pole here, okay, because south pole nature arises from magnetic property. Magnetic field travels south to north inside the magnet, so it must be forming a closed loop as per Maxwell, and must south pole will exist here. And it's like a Maxwell way of understanding why north and south pole can't exist, but there's actually also a like quantum level, atomic level things, that alignment of electron and all, that why north and south pole exist. But one thing is clear, that it will always be in loop. If it in loop, if it will not be in loop, it will not come back, and divergence will not be 0. If it's coming from there, it must come back to here, because to make the loop and divergence 0, and doesn't violate Maxwell law, okay. So that's what about it. If we ever generate it, it will come back again to make the divergence 0 at that point. So that net field passing through in passing out will be 0. As you can see here as well. If I take any point here, okay. If I take any point here, at that point the divergence will be 0. If the field is coming in, equal amount of field is passing out. It's not like it has less number of arrows, so it seems like it's not true, but it is true. As much field is passing in, then same max flux of field is passing out through that surface area. Okay, so that's our thing. Okay, and it's always form closed loop. If you will see here, it will always form closed loop here. Why closed? To make that Maxwell law doesn't violate. Okay, so that's, I think you have understood alpha, and I didn't elaborate the first law. Okay, because if you do, it's like that first law later. First law coming to like Gauss law, and we transform this divergence into mathematical expression, as I have discussed, that we should transform it into mathematical expression, the flux by area, closed integral of flux by area during derivation part. So it will then transform into Gauss law, which is Q enclosed by epsilon. So like, still we have got this, okay, and I hope you understood. So this will not be like a regular video. Don't take it as like I'm creating a playlist or something. I will release content not based on trending, but on basis of what are the right steps, so that you can, if you keep watching my video, then you will understand the quantum modern physics in a well manner. So keeping that in my context, I will continue with this channel. Okay, so not only physics, it's like not only like a physics enthusiast, or it will also help like JES Brent. Obviously, it will help JES Brent. They have been taught like a Gauss law and all. So